In example 5, we're given a differential equation here which has both x and y on the right-hand side and also an initial condition. So the first thing we're going to do here is separate our variables. I'm going to show each step for this one on its own so that you can see how this works. So I'm just going to multiply each side by dx, and the dx's will cancel on the left, leaving us with dy is equal to x to the fourth times y minus 2. That kind of looks like an x. Let's get that out of there. So that'll be a y minus 2, and then there's a dx on the right. We haven't actually separated the variables yet because we still have this y minus 2 on the right-hand side. So to get rid of that, we're going to either divide by y minus 2, or we can also multiply by 1 over y minus 2. Either way is okay. Whatever I do to the right side, of course, I've got to do to the left side. The y minus 2's will cancel, same as dividing by y minus 2 on each side. And on the left-hand side, I'll have 1 over y minus 2 dy is equal to x to the fourth, with a little bit of space here, x to the fourth, and then dx. I've now successfully separated my variables, and it's now time to integrate each side. On the left-hand side, this is that special case where we have a variable, in this case y, raised to the first power in the denominator of a fraction. This is the only time when we're going to need the natural log, but the antiderivative of 1 over y minus 2 is the natural log of the absolute value of y minus 2. Remember your absolute value sign there. If I use the chain rule in reverse to get back to the integrand, which is 1 over y minus 2, I don't have to do anything special here because the derivative of y minus 2, or the inner piece, I'm looking at this part right here, is just 1. On the right-hand side, our antiderivative is going to be x to the fifth over 5, and then of course we've got plus c. To solve for c, we're going to use that initial condition, which is right up here. F at 0 is equal to 0. So we'll take each variable and substitute 0 in. See what happens here. Got 0 to the fifth over 5. Kind of like using 0 as a number because 0 to the fifth over 5 is, well, gone. And the natural log of the absolute value of negative 2 is just the natural log of 2. So it's nice sometimes when we use 0 because it makes the arithmetic a little bit easier, or the solving process a little bit easier. We're now going to choose that line when we included the c for the first time, and so we'll have the natural log of the absolute value of y minus 2. That's equal to x to the fifth over 5, and then plus the natural log of 2. Some people will put the parentheses there by the 2, and some won't. So just know that that means the same thing. To solve this, we need to remember that the natural log is actually a log base e. So you can write it like this if that helps remind you of what that base is. And we're going to change this then into an exponential. So the base is e. The exponent is always on the other side of the logarithm. So that's x to the fifth over 5 plus the natural log of 2. That's supposed to be an x over here. Hopefully you can see that. And that's supposed to be a 2. And then on the right-hand side, we're going to have the absolute value of y minus 2. Oftentimes, on the left-hand side, this is simplified a little bit, and that's simplified into e to the natural log of 2 times e to the x to the fifth over 5. So you can do that because your rule when you multiply like bases with exponents is to add them. So the natural log of 2 plus x to the fifth over 5 is the same as the above. We also have this absolute value to deal with. So to deal with that, we're going to remove those absolute value bars. We're going to leave what's inside, the y minus 2, and we're going to put a plus or minus here on the left-hand side. Now remember, I'm going to switch sides on you here. So we got y minus 2 is equal to, and then e to the natural log of 2 is actually just 2. And then we have e to the x to the fifth over 5 power. The last thing to do here is to add 2 to each side. And we're almost finished. We've successfully solved for y. But the very last thing here to do is to take into account our initial condition. So you don't have to do this substitution, but you can to help you figure it out. And what I'm going to do here is I'm going to use that initial condition again, just to help me with this plus or minus sign, because I got to pick one of them. So what I'm going to do here is I'll just take that x being 0 and y being 0 and substitute that in to this line right here. And what ends up happening is we have 0 is equal to 2 plus or minus. Now e to the 0 power is 1. So we'll be left with 2 over here. And of course, the only symbol that we need for this one, or should pick, is the minus sign, believe it or not. So on the right-hand side here, to make that choice with the plus or minus sign, we know that needs to be a minus sign to make that initial condition work out. So here's your final particular solution that has the ordered pair 0, 0 as a solution.